So we created the different tables. Now let's try to add some data to this structure. As you can imagine, now it is important in which order you record the data, because, for example, if you want to add first the employee, then you will need the department ID. But if you haven't recorded yet the department, then simply you don't know the department ID. So first you have to add the department, then the regions, then the city, then the addresses, and finally the employee. So this is how you are able to add the different data. So let's start them. First of all, I go to the departments table, edit, and add here a department. There will be the first department, and it will be called as department A, like earlier. If you click to another row, then it is saved, as one can see. Then let's record the region. Edit top 200 row. The first region will be region A. Again, if you click to another row, then it will be saved. Then we record the city. Edit. It will be the first city. It will be city A. The postcode is 111, for example, AB. And the region ID, that it be 1. It will be in the first region. Saved. Then I create an address. It will be the first address. Address A. And it will be in the first city. And finally now we can create an employee. It will be the first employee. The employee name will be A. Department ID will be the first department and the first address. That's all. So we again recorded the same data like earlier. And now let's try to query the same information. If you right click on the employees table, select top 1000 rows, then it will give you the employee name, department ID, address ID. But unfortunately, for us as a human, the address ID and the department ID doesn't mean too much. So we want to know the department name and the address and city and information, something like that. Of course, you can right click on the departments, select 1000, find the first department ID, it is department A, but then you have to search for the department ID, department name manually. And it's quite boring. And of course, if we have computers, we want to do this work by the computer, done by the computer. So how to do it? First of all, we write the select star from, and first we select from the dbo.departments everything. This is the first query that we have already written to query everything. Oh, sorry, I made a mistake. dbo.employees, yes. And we query every information. But now we want to get the department name belongs to the first department ID. How to do it? We have to do a so-called join. So we write here join. The join has different types, and it will be a so-called inner join, because we want to search for this department ID, the corresponding department name. And the department name can be found in the dbo.departments table, so we just copy it here. And we have to say that we want the department ID in the employees table to be equal with the department ID in the dbo.department department. So on, and the dbo.employees dot department ID, just a moment, department ID, it should be equal with the dbo.departments dot department ID. And execute this query. We see the employee name the department ID, and here is the department name. As you can see, now you got the department ID even 2 times, once from the employees table and the other times from the departments table, because I said star to print me everything. So it may be a bit too much. So let's print only the ID, that's the employee ID, comma, then the employee name, comma, and the department name, from those tables. And as you can see, you got the information. Just for the fun, let's print the department ID as well. And if you try to execute it, you will get some error message. Department ID. Of course, I got an error message, but again, you will. So I did not get an error message because I made a typo here. Yes, so here is some problem. Unfortunately, I mistyped the column name. Let's try to correct it. Department ID. Okay, so I corrected my typo. Sorry for it. And if I run again my query, then I get an error message: invalid column name department ID, ambiguous column name department ID. The problem is here that the department ID column is in both in the employees and both in the departments table. That's my problem. If I correct the other name here, then it will still not work. So this is the ambiguous column name error message. So the problem, the computer doesn't know from which table I want to print the department ID. Of course, in reality now it is totally unimportant. Why? Because I said those two must be equal. So it's totally unimportant which one you choose. But of course the computer is only a computer. So you have to exactly define, I want to query this one or that one, even if they are equal. And now it prints you the information. So now we was able to query the same information. Unfortunately, in this case, we had to print too much characters, so I had to type too much characters. Let's try to abbreviate it a bit, because for example, here you had to differentiate between the two department IDs, so you had to write here the table name, and it was a bit too long. So let's call, for example, this dbo.employees table. You are able to give it some alias name. For example, I will call it as E, like employees, and D, the other one, a D, like departments. If you do this simple alias naming, then you will be able to call this one as E, and this one as D, and again this one as D or E. It's totally unimportant. So this alias name for the tables is very handy for you, because you should type much less characters, so there is much smaller chance to mistype anything. As you can see, it works exactly like earlier. Now, one more thing. Let's go back to and query the star, so everything, and we will get here the information address ID. Of course, this address ID doesn't mean too much for us. So let's try to get the address itself. How to do it? As you can see, the address itself in the address is table. So like we did it earlier, we have to write an inner join, and this table is called as dbo.addresses. So I just pull it here, and I will call this table as A. And I connect them on the following way. In the employees table, so in this table E, there is the column called address ID. So this one, so E dot address ID should be equal with the A dot address ID. And let's try to run it on this way. And we got the address and the city ID. Again, we have the problem. The city ID doesn't mean too much for us as humans. Let's get the city name. Again, we will write some inner join, and it will be called as dbo.cities, and I will call this table as C because I don't want to type so much. And the connection is the following. In the addresses table, so in the table A, there is the the city ID, and it should be equal with the c.city ID, and execute it again. Oops. So there is a deploy again, execute, fine. So the next one, we have the city and the postcode, and there is the region ID. The region ID doesn't mean too much for us, so let's write the region name. So inner join dbo.regions, I will call it as R, and on in the C table there is the region ID. It must be equal with the R.region ID. And let's run it, and we got every information possible. Of course, the region ID is unnecessary, the city ID is unnecessary, address ID unnecessary, and so on. That's why instead of the star, we are going to write here some list of columns. For example, we query only the employee name, comma, department name, comma, address, comma, city, comma, postcode, comma, region name, postcode, comma, region name. And if we execute on this way, we will get all the human readable information from those tables, and all the unique IDs are important now for us. So this is how we can join multiple tables together to get all the necessary information. Now we have one more problem, or many more problems, but one is the one that I want to talk about. And this is the following. I go back to the employees table, edit top 200 rows, and for example, I say that he works on the department 2. Click on another row, it is saved, exit, and execute. As you can see, I got no result. But this is the problem. The problem is the following. The problem is that I was able to enter the value 2 as department ID. In spite of that, I have not yet recorded the department ID 2. I write back it to the value 1, go to another row, saved. Now it executes, it's fine. So the problem is that, as I mentioned, we had to record the data in a given order. We wrote the departments first, then the regions, cities, and so on, because I wanted first the department ID to be created, and then we were able to refer to it in the employees table. The problem is that you are able to reference even to a number which not yet exists in the departments table. Is it a problem? Who knows? Maybe it is a problem, maybe it is not a problem. Just depends on the situation. Most often we do not like this kind of situation. Of course, you are able to enforce this from an application, and then you don't have to care about it at SQL level. But now, because we are dealing with SQL, we will solve this problem at the SQL level. So what we are going to do, we told that there is some connection between those tables, what we have written here. For example, here as department ID to the employees table, I want to enter numbers, only those numbers which are already exist in the departments table, and I have not enforced this kind of constraint yet. How to enforce this kind of constraint? This is the so-called foreign key constraint. Why is it called as foreign key? Because to here I want to add only values for a different table which exist there. So let's create those kind of foreign key constraints. There are many ways to create the foreign key constraint. For example, you can come here to the case, a new foreign key. That's one possibility. If you want, you can use this solution as well. But I prefer the other solution. There is the so-called database diagrams, where you can see in graphical form how your tables looks like. And then you are able to simply use some drag and drop technique to define the foreign key constraints. So I come here to the database diagram. It gives you some warning, some necessary object not yet created. Do you want to create them? Of course, because otherwise it doesn't work. So click on yes. And now the only change what happened, if you click on the database diagram, this error message doesn't come again. Now, new database diagram. And here are my tables. I want to add all the tables except table 1, which was my first simple example. And here are my tables added. So I have here the employees table. Here is the department table. And there will be the address. The address and the city. And finally, the regions. So those are my tables. And what do I want to do? I want this department ID. I want to select department ID only from this departments table. How to define this kind of constraints? First of all, I have to guarantee that departments IDs here are unique. Why? Because, for example, if there are two values, then which one to join? So it can have some contradiction. So first of all, if I want to reference to this department IDs here, I have to define this one as a primary key. So right click on it and set as primary key. And it will show me the little gold key icon next to it. And then I want the address ID because I want to do the same thing on the other direction. This address ID to be primary key as well. This city ID to be primary key as well. And this region ID to be primary key as well. If someone has used the Access, that surely knows this kind of window, and easy to do it. And let's save the modification. It has a very interesting feature. You have to save the diagram. When you save the diagram, then it will save the changes in the table as well. It says it will modify those tables. Do you want it? Yes. Okay, it's modified. Now let's do the connection. To do the connection is very simple. What I want to do is to select department ID from here, from this table, and it immediately gives me some foreign key, that FK relationship, and this foreign key will connect the employees and the departments tables. And the primary keys, so the gold key should come from the departments table. That's what I wanted to show if I connect them again. So the primary key table is the departments, department ID, and the foreign key is the employees department ID, because the name of the two columns is exactly the same. That's why the computer immediately show you most probably you want to join those two columns. Of course you can change it, but now we want to do just exactly what the computer is supposed to do. And okay, we have defined some connection. Here you can see an infinite sign and the key. What does it mean practically? Here you define every department one time. For example, you record the first department and the department name, but here many employees can work on the department ID, so you are able to use the department ID in many rows. And that's why you have the infinite sign here. And this is what we want to do. Now let's do the same stuff to the other direction. We have here the address ID and address ID. We just connect them. Again, we want to connect the address ID with the address ID because the names are exactly the same. The computer supposes that we want to connect those two columns. And yes, exactly this is what we want to do. Of course, you are able to change it, but now I don't want to change. And you want to connect the city with the city. the city ID. Okay, and finally the region with the region. Okay, one more thing on this table. There are some specification, this insert and update specification, and there are no action delete rule, no action update rule. What are those means? As we have already mentioned, if you define a foreign key, then practically you define that. For example, now I'm here in the city and regions. I define that I want to able to write here only a number which already exists in this other table. So to the cities table, I want to write only a number which already exists in the regions table. But what happens if you delete a row from the regions table? What to do in this case? And that's the delete rule. But the default setting is no action. It means simply that if you want to delete a row from the regions table, it will check that if there is any row in the cities table which uses that region ID, and if so, then it will not allow you to delete that row. It's so simple. So practically first you have to move every city to a different region, and only after that you can delete the region itself. The other one is cascade. It means if you delete a region, so delete a line from here, then it will delete every line from the cities table where that region ID is used. Sometimes it can be useful. Set null. The next settings. What does it mean? If you delete a row from the regions table, then it will set the region ID where it is used in the cities table to null. So every where it was used is set to null, the region ID. So it is not as hard as deleting the whole row, just setting that value to null. And set to default. That's the next settings. When you define a column, you were able to set if you allow null value or not allow null value. There are many other settings where, for example, you are able to enter a default value. For example, default region ID. Of course, it has not too much sense in case of region IDs, but in some situations, for example, for VAT calculations, economics, maybe it has some sense. But now it has no. So what does it mean? If you delete region ID from here, then it will set to a default value what you have already entered, and it will use that value. So those are the possibilities. Most of the times, let's say in 80% of the time, we use the no action, but sometimes the other can be used, and the same can happen in case of update. For example, you change the region ID from some reason, and what happened with the cities belonging to that region in that case. Again, the same things you can choose from. But now we will leave it as no action and OK. So we define the connections. Let's save it. Save. Yes. And the modifications are saved. Now I close the diagram, execute the query. It works fine. And let's try now to change the value. For example, I go to the employees table like earlier, edit the top 200 rows, and change the department ID to 2. As you remember, the 2 doesn't exist. If I clicked on other row, I got some error message. No rows was updated. So it states that there is some foreign key problems. Correct the error or press ask to cancel the changes. Now I press the ask button to cancel the changes. Of course, in this case, you are able to enter the value 2 only if first you record the second department, what will be called as department B. And if I edit again the employees table, now I can select here the 2 and write it. As you can see, there is no error message. But if I write here 3, now I got again the same error message because there is no department with the ID 3. So this is how the constraints, the foreign key constraints are working. And now let's continue with some other stuff. We have created here this simple database with those simple tables only to show you how the foreign key constraints can be defined and how the tables and columns can be created. Now let's start to use some databases. First we will use the Northwind database. This is a Microsoft example database. So let's come here and let's try to use this database. First of all, what's the problem? I want to query some information, and if you want to query some information, you should know what kind of tables are in the database. Of course, now there are not too much tables, so I can run through them and I can read the name of them. And I want to know what kind of constraints, like we have defined earlier, exist between the different tables. To get the information what kind of connections exist, we can use again the database diagram. So if you come here, right click, new database diagram, you can select the tables. For example, you can select the employees, the customers, the orders, order details, territories, and whatever you just want, and add them to the list. And if there are foreign key constraints defined, then it will immediately draw you the different connections. Like here, we can see that there are employees. The employees belong to different territories. There are orders, and the different orders belong to different employees. We can check that tables and columns, so the employee ID are joined. So here is an employee ID, and here is an employee ID as well. And for the orders, there are customers, and there are the order details. For the customers, there is a customer ID, most probably here is a customer ID as well, and so on. So we are able to simply find what are the connections. Here is an order ID, and there is an order ID too. What is the connection between the different tables? Let's try to query some basic information. So if you have this kind of diagram, then you are able to design your queries practically. So it's always worth to create those diagrams and print them and use them. Okay. First of all, let's create some simple queries. For example, we want to see all the employees. It's very simple. Here is the employees table. Right click, select top 1000 rows, and gives you the employees. Of course, the computer writes the query on the way it gives all the column names, but maybe you just simply write it like select star from this table.employees table. It's exactly the same. And as you can see, we have 9 different employees. So those are all your employees. Now let's try to get some other information. For example, we have the orders and order details table. Let's get the order information. So for example, in case of which order, we ordered what kind of product, how many of them, what was the price, and so on. How to do that? If you recall the previous diagram, but let's just do it again. We have the order and order details table. Let's add them. Close. As you can see, there is a connection between them. Here you are able to check if you click on it. The connection between them is done by the order ID columns. So practically, every order has a unique ID, and for one order there can be many products ordered, and that's why we have here this order details, practically that contains all the products ordered with unique price, quantity, discount, and such information. So I go back to the query window. First let's query select star from this dbo.orders table and execute it. Then I got all the orders, but unfortunately now I do not see the products. Let's see the different products viewing the different orders. So that's why I will join the order details table, and I will query this product ID information as well. So I will use the inner join to join the dbo.order_details table, and I will call the first one as O and call the second one as OD because I don't want to type so much. Then I will connect those two tables on the following ways. On the orders table there is the order ID column and it must be equal with the od.orderID. This is how we can join them and execute. As you can see now, for example, you can see that in the 1024 order ID there are 4 products altogether ordered, and those are the following ones. Where is the product ID? The 11th, the 42nd and the 72th. Those are the prices and quantity of them. Maybe you will see that it's a bit too much information. I got too much columns. It's difficult to find the relevant information. I want to know only the order ID. I want to get only the product ID and the unit price and the quantity. So those are the only informations what I want to know. So I will use the following columns only: O.orderID, comma, od.productID, comma, od.quantity, comma, od.unitprice. And that's all what I want to see. And then all the other information doesn't disturb me. One more thing, maybe you want to see the price. If you want to see the total price, then you have to multiply the quantity with the unit price. It's very simple to do. You just have to create here a new column and it will be the od.quantity multiplied with the od.unitprice. And then you will get the price of every line. This one is 12 times 14, that's 128, and so on. 10 times 9.8, that's 98, and so on. It's a bit ugly because it has a column which has a name, no column name. It's a bit ugly. Why I got this information? Because the order quantity times unit price is a calculated column and it simply doesn't know how to call it. No problem, we give it some name, for example, total price. If I just write it on this way, as you can see, I got some error message. Why? Because there is a space in the column name what I want to use. You have many choices. For example, first of all, I recommend you to not use any spaces. For example, you can use the underscore instead of the space, and it works fine. Or if you want to use space anyhow, then use the square brackets around this text. And if you run it on this way, it will be called as total price. ManySQL accepts the apostrophe here as well, instead of the square brackets. More exactly, the square bracket is Microsoft SQL specific. Most of the SQL like the apostrophes or the quotation marks. It depends on them. But as you can see, this notation works in Microsoft SQL as well. If you give some alias name, then you can use the S keyword. It is, as you can see, not mandatory, but it's exactly the same. The same is true here in case of the tables. You can use the S keyword if it helps you as a human. Some SQL doesn't like the S keyword here for the table names. It again just depends on the front end of the SQL server. Try it if you want. So this is how we can query the information. The next very interesting stuff, if I come back here, I was able to connect the order and the order details information. If I right click here and add some tables, here is, for example, the employees table. Close. If I add here the employees table, you will see one interesting thing. There is a connection from the employees table which connects back to the employees table. If you see something like this one, it means some kind of hierarchical structure. If I use the paint The situation now is that those employees table are described some kind of structure. So you have here some boss who has some people and those people again, some other one, and so on. So this kind of hierarchy. So this one is described with the so-called self-referencing tables, like this employees. In this case, if you click on this line, you can check the employee ID and the reports to are the two columns which are interconnected. So practically here as reports to value, just a moment, I have to find it. Here it is, reports to. So the values here in this reports to column must be some kind of employee IDs. So what we want to do, we want to write a query where we are able to query every employees and the boss of every employees. This is what we can use, this kind of hierarchy. First of all, let's create just the whole table to see how it looks like. Select start from dbo.employees and I will call it as E. And let's execute. Here are the information. And here is this reports to column. And what I want to do for every people, for example, to this Davilo Nancy, I have to find who is his boss. Says it reports to the employee number 2. If you check the employee number 2, that's the Fuller Andrew. So I want to get Fuller Andrew as the boss of David Nancy. One more thing, now if you check, there are 9 people working for this company. So again, I have to get the boss, the name of the boss, and the name of the boss is in the same table. So what to do? We just write an inner join again. But now we join the table with itself, so dbo.employees. And we will call this table as, for example, it will be the boss table. Earlier I mentioned you can give the tables this alias name. Now if you join the table with itself, so it is a self join, then you must give an alias name, at least one of them. Otherwise it shouldn't work. Why it were not working otherwise? Because here to the on you were not able to write the condition, because now I am able to differentiate between the two columns only because they have the alias name. They have the same table. So if you don't give them alias name, then how to differentiate between the two tables? There is no way for that. That's why if you join the table with itself, you must use at least in one case the alias name. So in this case, the employees has a reports to column, and it must be equal with the boss employee ID. And if we execute it, we got the required information. Of course, it is a bit too much. So let's filter the columns. Instead of the star, I will write I want to print from the employees table the first name, and from the employees table the last name, and from the boss table the first name, and from the boss table the last name. Execute. It's much better. For example, to Nancy Davilo, I get that really Andrew Fuller is the boss. Now it is a bit difficult to read because this is first name, last name, last name. What is the difference between them? Again, it's better to give some alias names. For example, here I will write employee first name. I will call this column as employee last name. I will call it as boss first name, And we'll call the other column as boss last name. Execute. It's much simpler to read now what is the meaning of the different columns. There is one more problem. When you query everyone from the employees table, then there were 9 people, but now only 8 people. What happened? If we query again all the employees, select 2002, you will see this Fuller Andrew, who has no boss, equals to null. And this null causes the problem here, because here we want to find to everyone a pair. But we are not able to find a pair to the null value, even if there were some null value in the boss table, but there is no, even that we will not find because the equal, as you remember, the null is not equal with null. So you will not got any information even in this case. So the problem is that one people was simply disappeared. So the topmost people was simply disappearing. To solve this kind of problem, you have to use a different type of join. This is the so-called outer join. Outer join. And there are 2 kinds of outer join. One is the left outer join and the other is the right outer join. For example, now I want to get the following information. I want to get back every employee, even if the employee has no boss. And as you can see, the employee table, if I just put them in one line, then it's simpler to see, the employee is left from the boss. So I have to write here left outer join. So practically it means from the left table, so from this table, I want to get every information, even if it has no pair in the other table. Execute it, put it back on the previous format. And as you can see, now I got back 9 people. Here is the Andrew Fuller, who was missing earlier, with the null values. Of course, there is another from the right outer join, but it has not really meaning now. If you execute it, you will get some stupid results. Practically, it means you want to get back every boss, even if has no people belong to that one. So practically, everyone is selected as boss. Those are who has no employee names next to them. Those are not really boss. They are not the boss of anyone, practically. So it's just some bad queries now. So you have to carefully decide from which table you want to query every name. But now it is simply to decide. Simply you want to get back every employees, even if that employee has no boss. Maybe it is simpler to graphically remember to this one. We have until now 3 kind of joins. The inner join, which can be graphically represented like that. We have 2 sets, like these ones. And for every values, it will select the corresponding pair from the other table, and it will print the result only if it has a pair. So it will print only those ones. There is the left outer join. Left outer join. And there is of course the right outer join. Right outer join. In those cases we have again 2 sets, like those ones. We have 2 sets or 2 tables, it just depends on you which name is the better for you. And in case of left outer join, it will give back everyone from the left table, even if it has no pair. Of course, if it has pair, then it will put there the pair. If it has no pair, then it will write there null. and the right outer join, it will give you back everyone from the right table, even if it has no pair in the left one. Of course, if it has pair, then gives you back the pair as well. If it has no pair, then writes there null as value. So these are the difference between the three joins, the inner join, the left and the right outer joins. Until now, we wrote these kind of queries manually, so we typed here the selects. Of course, there is a possibility to use the so-called query builder in case of Microsoft SQL. It is called in that way. So if you right click here and select from here the design query in editor, then it will give you some kind of window. It's very similar to the previous one where we created the diagram. So we just select the employees table 2 times, and as you can see, it immediately recognizes that there is a connection between them. Here it is, and it was connected the reports to equal to the employee ID. And if you click to the top of it, properties, here is the alias. You can call one column as employee, and you can call the other column as boss, like this one. And I want to query only the last name, first name, last name, first name, first name. And I want to give this column an alias name. It's here. Alias, it's here. This is the boss last name and boss first name and last name and first name. Great. And as you can see, the designer wrote us the SQL select. If you click on the OK button, this is practically it wrote us exactly the same select what we wrote manually. If you execute it, it's running exactly on the same way. So you can see again one people is missing. You can change the inner join to left joint if you want, or just go back to the design query editor. Oops. I have to select the query. Design query in editor. Yes, here it is. And if you click on this connection or bring here your mouse, it means inner join. And if you right click on it, there is a possibility select all rows from employee or select all rows from boss. If you select all rows from employee, this is what we have done. You see that the sign is a bit changed, and it changed from inner join to left outer join. In this case, maybe because of this text, it's even simpler for the human to understand what happens here. We will select every row from the employees, even if it has pair or not. We don't care. If it has pair, then we will write there the pair value. Otherwise, we will print there null because we have no other shards. Click on the OK, execute it. We got back all the 9 people. So this is the query builder. Of course, you can use this one as well. It just depends on you which one you prefer. Sometimes it is faster. For simple queries, it's maybe faster to use the query designer. For more difficult queries, when there are some subqueries and group bys and whatever, maybe it is faster to type it manually. So it was the simple joining, and now let's continue with some other material. Now let's try to examine some kind of filtering, so some where clauses. First of all, let's select every employees from the employees table, and I will call it as E, just if I have to write something, I don't want to type so much. Execute, here are all the employees. Now let's try to write some filtering. For example, I want to get only the people whose first name starts with letter A. It can be written on the following way. where the e dot first name like, and here I will write the following thing. In case of normal languages, so in case of not SQL, you will write a star, for example. But in SQL, in case of the like, the star is the percentage sign. So it means the a, and after that as many characters as you want and whatever characters we want. And execute, and it will really print you only those two lines where the first name starts with a. And let's see the following. After that, we want to query only those people where the name starts with a, after that something, and after that d, and after that whatever we want. Now again, in case of most of the languages, you use the question mark to substitute one character, but in case of the like, you have to use the underscore sign. It means the one character and whatever that one character, and it's only the end-view folder. So practically for the like, what you have to remember, like, the star is the percentage sign, and the question mark is the underscore sign. And based on that, you will be able to create some simple expressions. One more thing, there is the birth date column. Let's query some people. For example, let's query where the a dot birth date is greater or equal than, for example, 1952 dot February 19th of February, and less than or equal 1958 9th of January. And if we execute it, e dot birth date, I forgot it, e dot birth date, point, not comma, execute, and I got 3 people as result. Those are the 3 people. It can be written in a different form. Instead of where birth date greater or equal with some date and less than equal some other date, you are able to use the between and. So where the a dot birth date between and this date. Execute. And it gave back exactly the same result. If I just go back, the between and includes the less than or equal, so a dot birth date, and greater than equal. So it includes the equal sign as well. I can prove it. For example, if you write, I just leave the equal sign, then as you can see I got back only one result. So clearly the between and is equal with the greater than equal and smaller than equal. So this is what it can substitute. Of course it is only a shorter form. If you prefer to use this one, then use that. Only the question of personal taste. And now let's do some other query. Let's query those people who has no boss. So the reports to field is equal with null. So where a dot reports to equal with null. As you hopefully know, it will not work because the null is not equal with null, and really it doesn't give me back any result. In this situation you have to use the is null version, execute, and really I got back Andrew Fuller, who is the only one who has no boss. And the next query, let's query those people who are older than 65 years. How to query this information? First of all, we have to use some function to calculate the difference between two date times. If you don't know which function to use, you don't have to worry. Here is the Northwind database, and here is this programmability container, and here are the functions. Of course, I want to know only the system built-in functions, and most probably it will be some datetime functions. And if you just read the name of the datetime functions, for example, here is this date diff. If you read the name date diff, or you Google search for it, then most probably you will find that really it is able to calculate the difference between two dates. It requires three parameters. One is the date part, so practically in what format you want to calculate the difference. For example, if you want to get it in years, in months, in days, or hours, or whatever. The starting date and the ending date. So if you want to query whose are older than 65 years, you have to use the following function: date diff, and in brackets interval will be year, comma, the starting date is the burst date, so a dot burst date, comma, and the end date is the actual date. The actual date can be queried with the get date function. It's here, and if you take a look, it doesn't require any parameter, so get date. But even in this case, if you doesn't give any parameter, it requires the opening and closing brackets, and that's all. Oh yes, and of course I forgot here the logical expression. It is greater than 65 years old. This is what I want to query. And there are two people who are older than 65 years. Those are. So this is how you can use the simple functions. And now let's talk about the indexes.